Yesterday, I almost died on my way here. And I'm saying that with a smile because obviously I didn't die, otherwise I wouldn't be here. And it's not a figure of speech. Before going to the conference, I was actually coming down the streets, and while I was crossing the 7th Street on my way to the Lady Bird, at the traffic lights, a car slowed down, but didn't stop exactly at the traffic light, and so it hit me a little bit. So I fell with my shoulder on the hood of the car, but thankfully, all good. I'm fine, I'm here. But as you can imagine, I'm very glad to be here. I'm very glad to be on that stage. I'm very glad to be in person for one of the first Pi Texas in person since the COVID. And I'm really thrilled to be able to share what I want to present to you today on this stage to all of you. I'm David Melamed, and today I want to talk about a topic that is really close to my heart. About a year and a half ago, despite a well-paying job at Cisco, a wife and 4 kids, I decided to take one of these life-changing decisions. I quit my job and I decided to open a startup with 4 other friends. The reason for that is that I couldn't stand anymore the pain of working with security as a developer. You probably also experienced that, but security is hard. Security is overwhelming. And a lot of the tools that currently are available for everyone to use are really not dev-friendly. I don't want to see 1,000 findings when I run some SaaS tool. I don't have anything to do with that. I don't want to spend my time thinking of, okay, how do I fix all those things? I want something to be easy. I want security to be easy. I don't want it to be a tax. And so I started to think, how can I achieve that? First of all, when I'm looking online for security checks and security checklists, I'm seeing lists that are very, very long. But where should I start? And so we came up together with this approach of minimum viable security. With what? Minimum security? How those 2 words can work in the same sentence, right? This is probably what you're asking yourself. Minimum security? I mean, come on. When you're thinking about security, you're thinking maximum security, right? Everyone wants to be secure. Everyone wants to live in a fortress, right? No one wants to be attacked. So I hope everyone does, right? Yes, sure, but you probably don't want burglars to come and break into your house, right? That's not even a fortress, right? Okay, that's great, and I'm fine with that. I think that we should all start with minimum viable security, because what does it mean? So minimum security means that, well, you don't want to start with a list of 100 different items. That's too much. What you want is to understand what is critical and what is not. And like for MVP, when you want to start with your first product, you're looking for the minimum set of features that you want to define and to work on and to implement in order to release your product. The same way is minimal viable security. You want to be able to set your minimal set of security controls that you want to focus on in order not to be embarrassed when you're releasing your MVP. And that's why it's not just minimum security, it's minimum viable security. You want it to be viable. And so, how do you get to that? How do you find MVS? This is what I want to show you today. How you can define your own MVS for a simple Python application. And so this is an example of a list, and probably we could debate whether or not some items should be there or not. But let's go over all the different areas, because there are a lot of areas. It's not only the code, of course. But in the code, you should look for code vulnerability, of course. You want to start there. If you have secrets, you probably also want to make sure that you don't have any hard-coded ones. If you have libraries, and in Python you probably have a lot of libraries in your requirements.txt, you also want to make sure that you don't have any vulnerable dependencies in your project. Now that was the code. What about the infra? You're running in the cloud because you're building a product for the cloud. And so the first thing you want to make sure is that you don't misconfigure your cloud infrastructure, right? If you're running on Amazon, make sure you don't have any S3 bucket that is open to the world, right? You also want to make sure that you have a way to access remotely your account, and that the account is set up and bootstrapped in a more secure way. Now, we talked about the code, we talked about the infra, but now that you deploy your application, you also want to check out your runtime. It's running on the cloud, so what can you check there? One of the most popular tools is Pentesting. So you want to make sure you don't have a security hole, SQL injections, things like that. You need Pentesting. But you also have APIs. So not only your front-end URLs, you want to check them, you also want to check your API endpoints. And then you have your pipeline, because the way you're actually pushing your code to production, you have a whole CI/CD pipeline. You have, first of all, your SCM, the way you store your code, and you also have your whole CI/CD pipeline. And so there, you want to check a couple of things. First of all, you want to check the CI/CD itself, that it's set up in a secure way. For example, if you're using GitHub Actions, Jenkins, make sure that you don't leave it open. And for the SCM for GitHub, make sure, for example, I know you're set up MFA. Also, because you're working with containers like almost everyone today, you also want to make sure that your base image is secure. So also look there for vulnerabilities. But that's not it. It's minimal, but still, you have a couple of other things. Your data. Your customer data, your user data are really important. You want to make sure that they're encrypted. You don't want to see a GitHub token, for example, lying around in plain text in your database. What about multi-tenancy? Most of the SaaS platform today are multi-tenant. You want to make sure that there's no way you can read data from one tenant to the other. Otherwise, you will probably be very, very embarrassed. What about third parties? You have a lot of services today that are connecting to your product. Could be things like GitHub, if you have a GitHub integrations. It can be Datadog for analytics. It can be Hexagon if you have serverless. There's a lot of services that are connecting to your product. You need to make sure that they're secure. Otherwise, someone can take over your account there. And maybe there are some data that are sensitive. Now, we talked a lot about the code, the infra, everything that's very technical. What about people? We almost forgot that we had people that are working on the code and on the product. And there, one of the things that is very, very common, but sometimes forgotten, is use password manager. Seems like very basic. But still, how many developers here are saving or manipulating passwords in plain text, storing them in their local laptop, saying that, well, that's fine, or in some notepad? No? No one? That's great. So you should start with a password manager. And if you think that passwords are only, I don't know, username, password for your accounts, maybe there's more than that, and we'll get to that in a moment. And finally, there's another area, it's the operations. How do I make sure that when an employee leaves the company, well, I'm removing his access to GitHub? I need to manage that. And also, there will probably some incident, some security incident in the future. And so I need to make sure that I have some process in place, because that's something that is very stressful, and I don't want to add to that if I don't have a process in place already. So these are the different areas that are related to product security. And what I want today is to focus on a couple of ones, the ones that were actually highlighted. So I'll go really quickly through each of them, and I'll give an example of the tool that we'll use. All the tools that I will demonstrate here are open source, and you'll see at the end a demo that everything will be integrated into the CI/CD. And so you can really clone the code that I will give at the end, and you can have the start of your minimal viable security today. So the first area is called vulnerability. We want to make sure that we don't have any vulnerability in our code. For that, the most popular tool is SAST, Static Code Analysis, looking for specific patterns in the code. We'll use Bandit. Bandit is an open source linter for Python. And you have 35 rules that are already built in the tool. Then you have the secrets. For that, we'll use a great tool that's called Gitlix that is supporting a lot of different regexes of well-known patterns for secrets, for social networks, for AWS credentials, SSH keys, API keys, and so on. And the advantage is that it's also looking in Git history, so that even if you deleted from your repo, it actually looks back in the history and makes sure that you remove it completely. For dependencies, we'll use Safety. Safety is an open source / commercial product. If you use the open source version, the updates are only monthly. If you use the commercial, you get updates all the time. But it's very, very easily integrated into the CI/CD. And we'll use that to check if we have vulnerable libraries in our project. Next, we'll also try to deploy our project in the cloud. And for that, we want to make sure that we don't have any misconfiguration in our infrastructure. We'll use infrastructure as code, Terraform, in order to deploy and to create some buckets in S3, and we want to make sure that there's no vulnerability in our code. And for that, we'll use a tool that was written by Checkmarx called Kix, open source, that has support for a lot of different languages, and right now include 2,000 checks. Then we'll use some Pentesting. And for that, there's a great tool that is open source by OWASP called Zap. It's both a web application scanner, looking for very popular top 10 OWASP vulnerabilities. And also, it can check for APIs when you're providing some open API specification or some Swagger definitions. And for that, we'll use an interesting setup, because we'll build the container of our Python application, and then we'll run Zap against this image. Talking about Docker image, we also use Trivy in order to check if there are some issues in the Docker images, the base image that we'll use. Then we also want to check that in that specific case on GitHub, we don't have any user that don't use MFA, because in that case, maybe the account can be is vulnerable and can be attacked by someone. For that, there's not really a tool, and that's why in a few lines of code, we'll build our own tool. And at the end, a word about Password Manager. So you probably all use Password Manager, but how many of you are also using the command line for the Password Manager? So here, I want to show you how to use 1Password CLI, which is a great way in your bash profile to load some secrets into memory so that you can use them for a lot of different things that you need without having to store them in plain text in your bash profile itself. In the same way, if you're using Amazon keys, you don't want them to be stored in plain text in your laptop in AWS credentials, for example. That's the way they recommend. You want to use AWS Vault, which allows you to actually store them in an encrypted way in your own laptop. So I will just show you how to do that. terminal. And first example is a dummy password that I saved in 1Password, and I'm not logged in anymore. One sec. Okay, so now I'm logging the first time on 1Password, and then I can use the OP command line in order to retrieve some password. The nice thing is actually to save that into your bash profile so that you really never see the value of the password. The second example is using AWS Vault, and this is an example how I'm using it. So I don't have any secrets stored on my machine. Everything is actually encrypted, and I just need to use AWS Vault exec at the beginning in order to retrieve my policies and run any command for Amazon. And now let's talk about the different tools that I want to show you inside the application. So these are different tools I talked about, and now we'll see them in action. So the demo will be a very simple, fast API-based application that displays movie information. Okay, the actors that are playing in the movie. For that, we'll use a simple data persistence using SQLite. The SCM will be GitHub. The CI system will be GitHub Action. And our goal is to integrate the 7 tools that I showed you in a few minutes. This is the demo repository. If you want to check that out afterwards, it's public. You can clone it, fork it, whatever you want. First, let's see the application in practice. So it's a very simple application. I'm just starting it using UVcorn. Okay, and now, yeah, these are the number of movies in the database. I want to search for a specific one. Let's search for Titanic. Okay, there are 3 versions of the movie. I want the one from 1997. So let's see the actors in the movie. Okay, so movie, star, and then I can see the different actors in the movie. Very simple application, right? Now, let's see the code of this application. You will see that it's very simple, right? So we have a few endpoints and a bunch of SQL queries. Now, I want to show you, this is the Docker file. It has some AWS credentials because the guy who actually wrote that didn't know that it's not the best way to pass environment variables to get access to Amazon. And so what we'll focus for a few minutes is the way I configured the GitHub Action workflow, which includes all the 7 tools. Let's see how it works. So basically, you have a couple of jobs here. You have the SAST one, secret one, DAST for API security. You have infrastructure, SCA for dependencies, the container, and MFA. These are all the jobs that I want. Now, I can see here static vulnerability scanner. I'm using an action, GitHub action that someone actually already wrote, and it's encapsulating the bandit tool. And this is the way I'm running it. And at the end, I want to upload the artifact, the results, to GitHub itself, so that I will be able to review the results. And then I have the secret one. The secret is using Gitleaks. There's also a public action for that, so it's really easy to integrate. The DAST one is more complicated because, as I said, I built the image before. Here, I'm making sure that it's running before I run my my action. So it runs as a service. And then using Zap, I can go and use the Zap API scan, which will trigger the scan against this image. And for that, it will use the Open API definition. The Open API is actually something like that is provided by FastAPI, and it's defining all the different endpoints and the parameters. And then I have the infra. For the infra, I'm running Kix. Also here, there's a Kix GitHub action that is already implemented. And I put my code into a Terraform file, a Terraform folder. And here you can see that it's very basic. It's just a simple bucket in S3 that I want to create, and a very simple DynamoDB table. Now I have SCA, which is dependency check. For that, there's no available GitHub action, so I'm just running a script myself, installing it with pip, and then I'm running the command myself, looking to scan the requirements.txt. For the containers, I'm building the container myself, and then I'm using the action that is provided by Trivi itself in order to check if there's some issue. And at the end, MFA, I actually built it myself. I used 3 lines. If you excuse me here, it's in Node.js, though it's a Python conference, because here the API is actually easier to use. And what I'm doing here is that I'm listing all my users, all the members of this organization, of my organization, and I'm filtering the one that don't have MFA enabled. And I want to, I'm going over all of them, and if there's at least one, then I want this to fail. So I'm returning an exit code of 1. Let's see all of this in practice into GitHub. So I uploaded my repository here, and here you can see an example of a pull request. As you can see, everything is failing because I have a lot of issues in this repo. And if I'm looking the details, I can see a few things. So first of all, I can see that some of the tools are returning here their findings. Some are uploading their artifact that I showed. So I can, for example, open this one. And I'll do it like that. Opening the zip here, and I can see the results of the file. These are all the dependencies that were found in my code. They're actually SQL injections. For some of them, actually the results, it's inside the action. So for all of them, I can see the logs. And here I can see that I have some issues with my infrastructure. For the container also, it's inside the results here. So I can see that I have actually 2 issues with my Python. And so, as you can see, very easily I can integrate a couple of tools, and that's the basics of my MVS, of my security. Because here I have a lot of different things that are checked against a very simple code, and very easily I can get them into my CI/CD. So of course here, as you can imagine, the developer experience is not great, because you have some of the tools that are returning the results inside the logs. Some other are returning it as part of some artifact that you need to read. Some other are just maybe not returning directly this, and you didn't know UI. The experience is not great. And what you would like to is to have some kind of unified experience, a one single experience. For example, what would be great if all the findings were returned inside the PR itself as PR commands. And so this is basically what we did at JIT. We tried to take this a step further. And so, as you can see here, we wanted to be really dev native. And so every tool is now returning the results inside the PR in one single way, in a very unified way, as PR commands. Also, we wanted to manage our own customized MVS plan, not in a spreadsheet like many folks. We wanted it to be customizable. We wanted to see how the progress is. Wanted to make sure that all the tools that we're running are actually running and are configured correctly, because it's easy to add a tool, but maybe it's misconfigured. For example, maybe I think that the tool is actually checking for secrets, but maybe misconfigured, it's not looking at the right folder. And so everything together, we wanted to get this continuous security platform. And this is what we did at JIT. If you're intrigued by what you just saw and you want to know more, or you want to actually test the platform, I have a great news. Since Friday, we opened the beta to the public, so anyone can enter. Just need to register at g.io. Thanks for the DevRel guy of Elastic for the QR code idea. That's a great idea. If you're inspired by what you saw and it resonates, and you would like to be part of this task force that tries to empower the developers with security, then you're welcome to join us. And if you have any question, feel free to reach out to me. My email is here. I'll be around for the next couple of hours. I'd be happy to discuss with any one of you. Thanks again for your attention. And if you have any question, maybe I have some time for one question. Sure. Yeah. Yes. Okay, great question. So what I showed is only the beginning. It's basically the foundations of best practices, of things that you would need to start in order to have a product that is secure. But there are two problems with that. One is that if you're putting that into practice and you put that into your environment, you need to make sure it's working all the time. So you need to operationalize that. That would be the first thing I would say. And then it's only the beginning in terms of things that you need to do for security. There are a lot more items that you need to do. And so what we also did at JIT is we're providing this plan as a first one, but of course we have more advanced plan. Because maybe afterwards you want to go further, maybe down the road of compliance. So there you have ISO, SOC 2, all these different norms. You have the CIS benchmark. You have a lot of plans that are way more comprehensive in terms of number of items and things that you need to do. So it's only the beginning. I didn't want it to be overwhelming, but of course there's a lot more things that you can do in your environment to make sure everything is secure. Another question? It's great. Everything was clear? Thanks you again.